Hello Maths fans, this is a feedback and help for clips A13A and A13B, which are rearranging formulae. Okay, so we have covered this sort of thing before. We're using a balanced method, but I'm going to show you why we do this. So for example, if you look at the question I've got here, an example, it is an area of a triangle. Now, area we know is base times height divided by 2. Okay, or A equals B times H divided by 2. Now, in that equation, or that formula I should say, okay, what we've got is A is what we call the subject of the formula, because that's what we can work out. The subject is what we can work out by using the formula. Now, sometimes we don't want to work out the area. Sometimes we might want to work out the height instead. Okay, so what we really want to do is to make H on its own. So at the moment, A is on its own. We want to make H to be on its own. Okay, now if you look at this formula, I could write it as A equals BH over 2, because we know that the times sticks the letters to do, so together. So if I want to find H, what's stopping H being on its own? Well, the first thing we can see is the divide by 2 and the times by B. So if I put lines down each side now, you remember this from when we've done balance before, I need to get rid of that divide by 2 and that times by B, so I get H on its own. And the first thing I'm going to do is get rid of that divide by 2. We always try and get rid of the denominator first. So I'm going to times both sides by 2. Okay, now the right hand side, as you'd expect, we just end up with BH. The left hand side, we're going to times A by 2. Now we don't know what A is, so we just know it's A was originally there. We're timesing it by 2. That must mean now that we've got 2A. What's stopping H being on its own now? Timesing by B. So what we're going to do, we're going to divide both sides by B. The right hand side becomes H. Great, that's what we wanted. We times by B, then we divided by B to get rid of it. What goes on this side then? Well, what was there originally? 2A was there to start off with, and we're going to divide by B. And remember, if we show this like a fraction, we can say, well, 2A was there originally, divide by B. And now what I've done, by doing that, this is good enough. You could write it now as H equals 2A over B. It's the same thing. These two things are the same thing. But what we've actually done now is make H is now the subject of the formula. Okay, so what we're going to do now is I'm going to do some examples of this. Okay, so we start off with something like, try and use something similar to what's in the clips here. If we've got Y, let's do example 1. Okay, let's call that Y equals 3x plus A. And I want to make X the subject. Alright, so balance method again. Lines down the side. I'll make X the subject. What's stopping X being on its own? Well, times by 3 and the plus A. What we get rid of first? We get rid of the plus A first, just like we would have done with equations. How do I do that? I subtract A. I subtract A from this side. I must subtract A from the other side to keep the balance. So I take away A from the right hand side, we're just left with 3x. If I take away A from the left hand side, now this is where it seems a bit confusing. If we'd had a numbers here, we could easily just do the subtraction. But what's there originally is Y. And what we're going to do, we're going to take away A from that. So I'll just write Y, subtract A. Okay, originally was Y. I've taken away A from it, so I write that as what Y was originally, and I've taken away A. Good. Okay, now what's stopping X being on its own now? The times by 3. So what I'm going to do is divide both sides by 3. The right hand side easily becomes X. What the left hand side become? Well, what was there originally? We write out again. Y minus A, and we're going to divide by 3. I write it like that. Okay, so we can write Y minus A over 3 is equal to X, or X Y minus A over 3. Now either of those is acceptable. Example 2. So you can get all sorts of formulas here, and it's about using the inverse in the balance method to get to what you want. Okay, so if we had, let's have a look, Y equals 2x plus, let's call it CD, and I want to make X the subject. Again, lines. I'll make them a bit wider because I need a bit more space here. What's stopping x being on its own? The 2, the plus c, d. The bit easy to get rid of first is this bit here. So I'm going to take away CD from both sides first. The right hand side becomes 2x. The left hand side originally was y, and now we're taking away CD. Now what do I need to do? Divide by 2 both sides. That becomes x on the right hand side, and the left hand side, well, what was there to start off with was y minus CD, so I'm going to write that down, but now we're going to divide it by 2. Or we could write it as x equals y minus CD over 2. That over must go along everything that you're dividing by there. Okay, example 3. Sometimes you have fractions, okay? So we had a fraction a minute ago there, but sometimes you'll get I don't know, p equals 3d over a. And we might to make d the subject. You can make these up. You can make any one up, you know, any equation, any formula you like, so I should say, and rearrange it using this method. So I'll make d the subject. What's stopping d being on its own? Well, a 3 and the a, but I want to get rid of that a first because it's a denominator. It makes my life harder if I don't get rid of that. So that means divide by a, so I'm going to times both sides by a. So we get pa on the left hand side and 3d on the right hand side. Okay, the times by a has got rid of that divide by a, and I've times by a there. What's stopping d being on its own now? The 3. So we can divide both sides by 3. The right hand side becomes d, and the left hand side, well, what was there originally was pa, and we're going to divide by 3. So pa over 3 equals d, or d equals pa over 3. Okay, a couple more examples. Okay, just examples that I've seen that have come up in the questions for this, so we know what's going on. Example 4. What about if you had something like this? Y, let's use a different letter actually. Let's use this. Let's call it G equals a half A minus B. It looks really complicated, doesn't it? And I want to make A the subject. Okay. Again, lines. Okay. Now, the thing is about this, again, I said about this denominator here, if I timed this out, actually what we get is, that means divide by 2. That times by half same as dividing by 2. So what I could do is say that's 1 minus a minus b, 1 times a minus b, which is a minus b. That's the same as a minus b over 2, or 2 times 1, if a minus b had a denominator. So basically, to get rid of that half, it's the same thing here. All I've done is multiply that. But you might even see it here. To get rid of a half, what do I need to do? I need to times it by 2. So times the right hand side by 2. I'm going to times the left hand side by 2. So we get a minus b equals 2g. Yeah, I've got rid of the type divided by 2 there. If that was a third, I would times both sides by 3. If it was a quarter, I'd times both sides by 4. Basically what you're doing, if I'm timesing that by 2, I make it become a 1. And 1 times a minus b is just a minus b, which is what we've got here. Okay. I hope that makes sense. We're trying to do another one of these, actually, before we finish. So, okay, what am I saying? I want to make the subject a. So what's stopping a being on its own? The minus b. So what I'm going to do to both sides, I'm going to, you got it, I'm going to add b to get rid of that minus b. So it's the same as equations work that we did earlier in the year, but instead of using numbers, taking, subtracting, adding, dividing and multiplying by numbers, we're now doing the same with letters. So we had, this side will become a, if we add b, and this side was 2g was there originally, and we're going to add b. So that's it. Or we can write it as a equals 2g plus b. This is perfectly okay. Both of those are perfectly okay as answers. Okay, let's try another one. So y equals 5x plus 1 over 3. Now I'm going to show you, this question can be written in two ways. It's the same question, I'm going to show you exactly the same thing. This could have been written as y equals, maybe you can see this, a third of 5x plus 1. Now which one looks harder? I don't know, they both look quite hard, don't they? But I think when you've got the brackets in there and that fraction, it makes it look more complicated, but they're the same thing. What we're going to get rid of first, if you've been listening, hopefully you'll realise we've got to get rid of this 3, this denominator of 3. Okay, and the simpler way to get rid of the denominator of 3 is to times both sides by 3. So I'll start off with this one, I'll show it on this one, we get the same answer in both ways here. Times by 3 I get 3y on the left hand side, and the right hand side I get 5x plus 1. So I've times by 3 to get rid of that 3, times by 3 to get 3y. What's stopping x being on its own now? We're making x the subject. I meant to say that actually at the start. So what do we get? We need to take away 1 from both sides. And what's stopping x being on its own now? Times by 5, so we divide both sides by 5. Divide by 5, I get x. This side already had 3y minus 1. I'm dividing by 5. Okay, so that's what we get. Or x equals 3y minus 1 over 5. Again, either of these are correct. Does it work this way as well with this one? Well, look, same steps. Look, times by 3, we get 3y equals, times by 3, I end up with a 1 there, one lot of this bracket, which is 5x plus 1. So it doesn't matter which way it's written, these two ways, the first step will always be to times by 3. I think that's enough to be able to answer the questions, the interactive questions for clip 13A and 13B. So good luck. See you next time.